Hello, pre-algebra students. Mr. Lawrence here, and I gotta tell you, I'm in a good mood because I'm watching the Browns, and they just intercepted for a touchdown to Florida Jackson. Hopefully they don't blow it. All right, I'm making up a pre-algebra quiz prep video. This will help you get ready for Tuesday's quiz. All right, let's see what's going on here. Let's do a quick review of these funny-looking symbols. Remember the natural numbers? The natural numbers were things like 1, 2, 3, on forever, right? And they didn't include any negatives, no fractions, or anything like that, right? Those are the natural numbers. And then we introduced the whole numbers, and the whole numbers were just like the naturals, except they went with 0, 1, 2, 3, no fractions, no decimals, and that was how the whole numbers go. And so if a number is a natural number, it therefore by default is automatically a whole number. And notice the numbers are in both of the circles, the natural circle or oval and the whole number circle. And then we added in the negatives. So we might have dot, 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 and then like -2, -1, 0, 1, 2, and that would include the integers. Okay, and the integers encompass those. And again, still no fractions, no decimals, right? And the fractions and decimals show up in what we call the rational numbers. And those are all decimals that end, decimals that repeat, and all fractions. So decimals that end, decimals that repeat, and all fractions. Let me ask you this. Is 1 a rational number? Well, you could argue that it's 1.0, so therefore it's a decimal that ends. You could argue that it's a fraction. 1 over 1 is the same as 1, isn't it? So therefore it's a fraction. So therefore, yes, 1 is an integer. Notice 1 is in the blue circle over here, right? It's also in the red oval, the green oval, and the black oval. And then we talked about this really strange group over here. Let me get a different color here. All right. We'll make these our irrational numbers. They're over here by themselves. Okay, and those are things like pi, or decimals that end, that never end, never repeat, like 2.142 dot dot dot, right? Those are the irrationals. And your experience tells you there are more of these numbers, the naturals, wholes, integers, and rationals, than there are of integers. But actually, if you take high enough level math down the road someday, you'll see that there are more of the irrationals than there are of the rationals. Your experience tells you otherwise. All right, and finally, all of these together fit into the family of what we call the real numbers. And I'm just going to bring this here, and I guess I can bring that I there and put my Q in there. Oh, I guess I'll just get rid of those. Hocus pocus, out of focus. All right, so that's a quick review. So let's come down here and test this out. Let's look at these. -3. Is -3 a natural number? No, no negatives. A whole number? Nope. Is it an integer? You bet your boots. So it's an integer. If it's an integer, it automatically is inside the black circle, which makes it rational. It can't be irrational and rational at the same time, so I'll leave I out, and it is a real number. We only deal with real numbers in this class. In Algebra 2, you'll deal with imaginary numbers. Wouldn't that be cool? Oh, by the way, an imaginary number is not 11. All right, 5/6. Natural? Nope. Whole? Integer? No, it's not. It is rational because rationals include all fractions. It can't be rational and irrational, but it is a real number. All right, let's come on down here. 2.165 dot dot dot. That means that decimal goes forever without repeating. Automatically, you should be thinking irrational. And you are correct. It is an irrational number. It is also a real number. Okay, 0. Is 0 natural? No, it is not. Is it a whole? Yep. And since it's a whole number right here, it automatically is an integer and it's a rational number. It's in all those circles. So, it's a whole number. It's an integer. It's rational. And it is a real number. You should be able to do that on Tuesday's quiz. Switching directions now. We're going to add, subtract, multiply, and divide integers. So, if you want, see how well prepared you are, pause the video and then unpause it when you have your answers. I'm going to do each one. I assume if you're watching, you want to see my solutions. All right, -3 plus 7. That's kind of like 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7, right? These 3 will cancel with those 3, leaving me 4. This equals positive 4. 4 positives. -6 minus 2. Well, let's see here. If I had a number line, you can do it using counters. But if I was at -6 and I had to move 2 in the negative direction, remember the negatives are to the left, positives are to the right. I'm going to go 1, 2. Where would that take me? Well, that would take me to -8. Okay, -8. If you don't like that, use the counters. And none of these will cancel, therefore I have 8 negatives or -8. All right, number 7, be careful. Be careful. Danger, Will Robinson. It's a multiplication problem. The counters and number line thing aren't going to work. This is where we have Bobby walking on the number line. Or you can remember to count the negatives. Read this problem out loud. -6 times 2. I said the word negative once, an odd number of times, which makes it a negative answer. So -6 times 2, well, we all know that 6 times 2 is 12. I said negative 1 time, it's a negative answer. And there you go, -12 is the solution. All right, number 8, same type of problem as number 7. -4 times -3, I said negative twice, that's an even number. It's going to be a positive answer. 4 times 3, 12. Bam! Too easy. All right. Number 9, division works the same way as multiplication. -20 divided by -10, it's going to be a positive because I said the word negative twice. 20 divided by 10 is 2. All right. Number 10, 30 divided by -3. I said the word negative once. It's going to be a negative answer. 30 divided by 3 is 10, and there you go. Now, I'm not going to tell you number 11. I want to see if you can do it on your own. Unpause the video when you're ready to see my solution. Here it comes. Hopefully you've tried it on your own. If you were thinking -10, you didn't pay attention that this said plus and not multiplication. I could use 5 negatives counters and 2 positives, and positives and negatives cancel out. And look at that, I'm left with 3 negatives. Or I could have done it on a number line. If I'm at -5, and I have to move 2 in the positive direction, -4, -3 would be my answer. All right, ladies and gentlemen, that should be the end of the video. Hopefully you take the quiz serious and do your best. Mr. Lawrence signing off. Good night, everybody.